Software engineering for software engineers. When software engineers begin to develop a new piece of software, they usually follow a developmental life cycle, which can be broken up into multiple stages. Some of the stages I'll be discussing are requirement validation and verification, the testing stage, and project refactoring. Although over time, these systems have grown more and more complex. This is due for the increased need of functionalities, also the need to meet the growing expectations of modern society, and the need to develop and deploy these systems in a timely manner. The challenges come in each one of the stages. So from the beginning, software must be planned efficiently and completely before development can start. And then the development itself must be structured, efficient, and thorough. And then testing must be complete and exhaustive. And ensuring all of this in every stage requires the proper allocation of time, money, and resources. So what can be a solution? More software. It's not a full solution, but it is certainly a helpful crutch for software engineers. And utilizing software to develop software helps reduce the possibility of error. So challenges in the requirement stage. So the goal here in the requirement stage is to construct a cohesive document that accurately represents the customer's requirements. And this will act as a contract between the company and the customer. So some issues in this stage come when the customer constantly is adding more features or changing requirements. And this affects development because development cannot actually begin until requirements are formalized and approved by the customer. And also before they can be approved, engineers have to identify dependencies between requirements and also conflicts between requirements. And this is done much easier when using organizational tools like FRET. So some challenges in functional testing. So the goal of functional testing is to completely and exhaustively test functionality of a certain portion of a software system before deeming it functional. So this can take time if testers are not prepared, because development can be stalled until testing is complete. And then improper testing can also result in cascading problems if it's deemed functional when it really was not functional. So the implication here is that software engineers want a structured way to execute complete and exhaustive sets of testing suites or testing cases. And this can be done with JUnit. Challenges in project refactoring. So the goal in project refactoring is to extract a certain piece of functionality from a legacy system or to restructure the architecture of an existing system, which doesn't have to be legacy, but it is in some cases. So some issues here are doing a proper cost-benefit analysis of a refactor to determine whether the refactor is actually worth it, if the usefulness outweighs the cost, and then actually being able to implement the refactor in a timely manner. And then there's always going to be a looming risk of complete failure when trying to refactor a certain system. And then when doing a refactor of an architectural overhaul refactor of an entire system, it's very complex if being done manually, right? Because there are lots of moving components, lots of variable tracking, and sometimes it can overwhelm the refactor, right? So the implication here is we want first a controlled refactoring environment, and we also preferably want management to efficiently analyze the refactor, which can't really be controlled in most cases. So FRET is a tool used by software engineers to help in the requirements validation stage. It was a tool developed by NASA and it was made open source. It can be used to programmatically represent requirements of a software system. And so requirements can be implemented into FRET and mapped out through the use of variables and functions. And if one does this, then FRET itself can actually identify conflicts with requirements. And that assists engineers in determining if a project is possible and or cost efficient, right? It saves extra work from the engineer having to identify these couplings or conflicting requirements and allows FRET to just do it. FRET also supports the exportation of its formalized requirements into any external analysis software resources, right? So FRET will convert its formalized requirements and send that to an external tool, which will then analyze the formalized requirements and produce some sort of suggestion, which FRET will then take as input, and it will actually integrate the suggestions from the external tool. It'll integrate those into its requirements after running them by the user, of course. JUnit is an open source framework. It's an open source framework for unit testing, and it can also be used for other types of testing, like performance testing using plugins and such. But here I'll be discussing unit testing. So JUnit supports functionality testing through unit testing. So a single test case can be represented as a Java class. And then in this test case, it'll have testing methods, which will test one piece of functionality of a system. And then all these testing methods should come together in the test case to properly test the functionality of a single class. Now, JUnit only is used for testing for Java code, hence J in JUnit. And many of these test cases can then come together to act as a testing suite to test the entire functionality of a system. So using this library and this framework can streamline testing. It allows software engineers to produce these tests early on, have them ready to just execute when they get sent code. And then for refactoring, IntelliJ IDEA is an integrated development environment. It provides an environment for complete and swift refactoring operations, such as variable function renaming, code positioning, dependence updating, and conflict identification and resolution when possible. And IntelliJ also supports external plugins. Many IDEs usually implement refactoring operations via plugins, external plugins, so they're not actually built into most IDEs, except IntelliJ has their own integrated refactoring operations. So this makes it sort of unique and stand out from other IDEs. Also, IntelliJ makes sure that if a refactor is implemented, it doesn't change the actual functional state of the program. And this is done by requesting approval from the user. So you'll do a refactor, and then IntelliJ will show you what it's about to do in its entirety, and then it will get user approval for these changes. And if the user doesn't approve these changes, then they won't be implemented. So future requirements in engineering. So automating requirement formalization would not be efficient because requirement formalization is a human-to-human process, right? It requires a lot of communication between humans, and so if effectively automating this with machines, it would not be efficient. It would lead to many inefficiencies and errors down the line. I believe that there are going to be advancements in these formalization tools through the conjoined efforts of software engineers. An example of this is that NASA released FRET as an open source program for the sole purpose of inciting further development on that piece of software. The future of testing advancements. So I believe that the future of testing will focus more on limiting the time between code submission and getting the results of this testing. So this just reduces the overhead of the testing stage entirely, right? And I believe that in the future, testing will be fully automated, and it'll be a standardization in the development cycle. And for project refactoring, I believe we're going to work towards efficient automation methods to refactor or at least reconfigure legacy systems to more updated versions. So the goal for refactoring these legacy systems, it should be to reduce the cost of a refactor so that software engineers will actually want to refactor a legacy system instead of creating a new one. So software is a major component of creating software because software engineers will use software to help them create software, and it can be applied to each life cycle in the stage. Software helps streamline these processes, such as testing. And between all these different softwares, a commonality seen between each different software is automation. These different softwares are used to automate monotonous tasks with the goal of reducing time, money, and resources. And that is it. Thank you.